calculator will help you factor polynomials. We're going to take a look at a couple of, well, three quadratic polynomials real quickly. And if you're looking at the first one, x squared plus 13x plus 40, we know that that is going to factor as two binomials. And we can, we know the first two terms have to be x to multiply together to give you x squared. And then the last two terms have to multiply. Whatever we put here and here has to multiply to be 40 and add to be 13. If you have a hard time with that, calculator will help kind of simplify things a little bit for you. Go to y equals and graph x squared plus 13x plus 40. Alright, we'll start with the standard viewing window. Alright, what we're interested in is where this graph crosses the x-axis. And I can see that that looks like it's happening at about 1, 2, 3, 4, negative 5, 6, 7, and negative 8. Now if I want to double check that, I'm going to go to second, calculate, and I'm going to calculate a value when x is negative 5, just to verify that we do have a y value of 0 there. And I'm going to calculate a value when x is negative 8, just to verify. So we do have x-intercepts at negative 5 and positive 8. In fact, let me do this. Let me grab that so I can draw on it. Negative 5 and negative 8. I think I may have said positive 8 and then I meant negative 8. Well, the way this is going to work, in order for x to equal negative 8, if you add 8 to both sides of this, x plus 8 equals 0. Well guys, there's your factor. So one of our factors is going to be x plus 8. Since the other x-intercept is at negative 5, you think about it this way: x is equal to negative 5. Add 5 to both sides. X plus 5 is equal to 0. There's your other factor. You should always multiply your binomials back together just to verify, to double check, to make sure that you do actually get 40 in the last term and 13x in the middle term. So if we're going to graph or try to factor x squared minus 5x minus 14, I'm going to pull out my calculator again. Start by graphing the equation. X squared minus 5x minus 14. We'll try the standard viewing window again. Okay, now we don't see the whole polynomial, but that's honestly not important. What is important to us is those x-intercepts. It looks like we've got an x-intercept at negative 2. So I'm going to check that out at x is equal to negative 2. Yep. So if x is equal to negative 2, then I know that my factor has to be x plus 2. And then the other x-intercept appears to be at 1, 2, 3, 4, 5, 6, 7. So if x is equal to 7, then x minus 7 would be the factor. So if you actually multiply that back together, just double check and make sure it works. X times x is x squared. X times negative 7 is negative 7x. 2 times x is 2x. 2 times negative 7 is negative 14. So that would be x squared minus 5x. That's a 14, not a 17. Minus 14. So we know we did that one right. Now, both of those examples, it's been really obvious what the x-intercepts were. We could look at the graph and tell where that was. In the next example, it's not going to work out quite that nice, I don't believe. 6x squared plus 19x minus 7. We'll start with the standard viewing window again. If we need to adjust that, we will. Okay, and it certainly appears that we need to adjust that. Let's see. I see one x-intercept there between 0 and 1. And maybe I need to make my x minimum something smaller. Maybe not. Maybe I need to make my x maximum something larger to see the other x-intercept. Maybe I didn't put it in right. Ah, that'll make a difference. If you actually enter the right equation, it helps. So let me just start over. 6x squared plus 19x minus 7. And we'll start with zoom 6. Okay, we do see two x-intercepts, but it is not clear. It's actually pretty clear that they're not going to be integers. So we're going to calculate this first x-intercept, the negative one. Calculate a 0, so we want option 2. And we're going to move the cursor to the left of that x-intercept. And I'll get there eventually. There we go. Alright, that's the left side. Now move over to the right of that x-intercept. Maybe right there is fine, I guess. Okay, negative 3.5 is that x-intercept. So what we want to do is we're going to think x plus 3.5 has got to be our factor. Calculate the other x-intercept, the other 0. Too far. Maybe right there. Left bound, right bound just to the right of that. Now, that's not a terminating decimal number. That's a repeating decimal number. You do not want to round that off. Alright? So here's what you want to do. What we need is that in fraction form, because we won't have to round it off. We'll get an exact value from a fraction. So quit and go home. Second quit to go to the home screen. What's happened is that that number is stored in x. So if from the home screen, if I type in x, it's going to give me what the x coordinate was for that last point. Then you can convert that to a fraction. So our other x-intercept is positive 1/3. So x minus 1/3 could be our factor. Now, that's a problem. When you look at those two factors, there's no way they multiply back together to give you x squared plus 19x minus 7. Here's the deal. Actually, let's change 3.5 to a fraction. So that would be, let's see, 3.5, 7/2. What we don't want are fractions. So take a look at your first factor and think about what you could multiply that first factor by to eliminate the fraction, and that would be a 2. If we do that, we'll have 2x plus 7. And then you do the same kind of thought process with the second factor. If you multiply that by 3, you'll eliminate the fraction, and that would leave you 3x minus 1. Now, those are your two factors for 6x squared plus 19x minus 7. Let's check. 2x times 3x is 6x squared. 2x times minus 1 is minus 2x. 7 times 3x is plus 21x. 7 times minus 1 is minus 7. So we'd have 6x squared plus 19x minus 7. Perfect.